Alright, this is for the next page, the back of the page, so the next 10 questions, so 11 through 20, I believe. I just want to say sorry. I just heard the video I recorded, and there is so much tapping. That's me writing with the Apple Pencil or whatever. I'm gonna try and write like softer so that it's not as like click click click. Whoops. So yeah. Anyways, I'll try and so it's not. It was bugging me the whole time I heard the video, and it was probably bugging some of you guys. So I'll work on that. But anyways, so yeah, we're on the next page, the back side now. So the next 10 questions. Hopefully you're done with 1 through 10. Remember, just always look for these two, set it equal to 0, combine like terms if needed, make sure it's in standard form, and then figure out which method you're using, whether it's factoring or square root. Okay, so I'm going to go ahead and skip to number 11. So we're going to be looking at number 11 for this one. So same thing, kind of look for your steps here. So it tells you to do set it all equal to 0 and combine like terms if needed. So now that I look at this one, this is actually equal to 0 already, and I don't need any like terms. So I'm going to go ahead and start solving from there. So I cannot do square root method because there is a bx term here. Okay, so this bx term, oh, I found a way not to click. Okay, so now I'm going to go ahead and look over here and kind of factor it from there. So now this is not a perfect square minus a perfect square, so I cannot do that. Now if you look at these numbers, there's no GCF you can take out from all of them. You cannot take out a 3 from 11 and a 4. So then your GCF here, you have none. So I'm going to look at the trinomial. So my a is equal to 1, greater than 1, or less than 1. If you notice, it's actually greater than 1 here. So a equals 3. So when that happens, that means that you're going to have to divide, but you have to multiply first. So I'm going to go ahead and multiply this a times c. Okay, this time it's not a 1 times a negative 4, it's a 3 times a negative 4, which will give you negative 12 here. Hopefully you can't hear my writing. I'm trying to write super soft. So now I'm going to rewrite it as n squared minus 11n minus 12. And that's where I'm getting the negative 12 from, okay, because it's down here now. So now I need to figure out, okay, what times what gives me a negative 12, but also a negative 11 here. And then it just so happens that it's going to be 1 and 12. That gives me a positive 12, but I actually need a negative 12. Now, I have to make the 12 negative, not the 1. Even though if the 1 is negative, it still gives me negative 12. The reason that the 12 has to be negative is because remember when you add them, you need a negative 11. If you make this one a negative, then you'll be left with a positive 11. So I'm going to go ahead and use 1 and negative 12. So I'm left with n plus 1 and n minus 12 is equal to 0. But the way that I got my a equal to 1 was by multiplying. So because I multiplied by 3, you need to undo that now. Basically, they're trying to take it back, okay? So I'm going to go ahead and divide both by 3. Remember I told you first check, does it give you a nice number? If it doesn't, simplify it and then cancel out your fractions. So the first one here, if 1 divided by 3, that does not give me a nice number, nor does it simplify. So I'm going to have to go ahead and get rid of this 3, cancel out the fraction by multiplying this by 3. Okay, so I'm going to do it on a different pen. Oops. So I'm going to be doing, basically what you're doing is, and I'm going to show you the first time. After that, I'm just kind of do it on its own. So you're going to have 3 times n plus 1 over 3. Okay, that means you're going to multiply it, distribute it in. You're going to be left with 3n plus 3 over 3. But this right here, 3 over 3, just cancels into a 1. So basically, let me erase this so I have room. So basically, you have 3n plus 1. That is what you're left with. Okay? Now for the next one over here, 12 divided by 3, that gives you a nice number, which means you don't have to do all of this. So because negative 12 divided by 3 is negative 4, then that means that your next one would be n minus 4. So these are your two factors. I'm going to rewrite them because it seems like they got separated. So my two factors are actually 3n plus 1 and the n minus 4. Okay, I'm going to set these both equal to 0. The first one is going to be a positive 4. The second will be a negative 1/3. And these would be your two solutions. Okay? And we did go over these before the break, and hopefully you're able to kind of do these in your head so that you don't have to keep doing this, because I know we went over that. So your solutions for this one would be negative 1/3 and a positive 4. Okay? Alright, let's go ahead and move on to the next one, and I'll leave that there. So now looking at this one, same thing again. Okay, set it equal to 0, combine like terms. I don't have to do any of that, it's already done for me. So I'm going to go ahead and do factoring method. I can't do square root. So now from this one I cannot do perfect square minus a perfect square. I have to check, is there a GCF? They do have a GCF. The GCF happens to be just a number. The number is 3. So I'm going to go ahead and factor out a 3 from everything. So this is what I'm left with. I'm trying to write slow so that you guys can't hear. So you're left with 7p squared minus 50p minus 48. There's nothing else you can factor out from these two, so I'm going to go ahead and look at my a value. The a value is a 7. Notice how it's still greater than 1. It's not equal to 1. So this is where you're going to have to multiply it and divide. So you still have to multiply these out. So I'm going to go ahead and multiply them. So 7 times negative 48. This is going to give me 3p squared minus 50p minus 336. By the way, I think either Miss Hallwalks or her dog are sitting outside my door. It's really weird. Okay. Alright, so from here, I'm going to go ahead and see that now your a is equal to 1. Now that your a is equal to 1, you're going to go ahead and try and factor it. So now your a times your c again, that gives me, and I'll write it down here so I have more room, 336. So now if I multiply 6 and 56, that actually gives me 336. And if I were to add these, let me write this way, 6 and 56. However, I need a negative 50. The only way to get that negative 50 is if the 56 is negative, because then I'll subtract it. So now I'm going to be left with 3p minus 6 and p, oops, oh not minus 6, plus 6, sorry, minus 56 is equal to 0. Now from here, remember, because you multiplied by that 7 earlier, you can't move forward until you get rid of the 7. So by multiplying it, now you're going to have to divide this. So I'm going to divide by 7. Okay? So now you have to ask yourself, okay, does it simplify? Does it get a nice number? So now for this one, let me change the color. These two, they can't simplify and they also don't divide nicely. So I'm going to have to multiply everything by 7. Once I do that, I'm going to be left with 7p plus 6. Okay? I'm not doing the work like I did over here. But all I'm doing is multiplying p by 7, which is 7p. I'm multiplying 6 by 7, which will give you 42 divided by 7, and it gives you 6. Okay? So now for the next one, 56 divided by 7, that does divide nicely. So I'm going to be left with p minus 8 is equal to 0. Now that I've actually gotten rid of the 7 that I had originally multiplied in and I divided it out, now you can go ahead and solve for these. Remember, 3 cannot equal 0. For this one, you're going to be left with p is equal to negative 6 over 7, because you subtract 6 from both sides and divide by 7. And then p is equal to a positive 8. So your two answers are negative, that's ugly again, negative 6 over 7 and positive 8. And then again, I have been giving you guys a key. So these are your two answers. So you're more than welcome to check those answers. Right now would be a good time again to kind of pause and try maybe a few examples on your own. If you don't want to pause it and just kind of go with the video, that's fine. But just so you know, I'm going to do the next two now. So 16 and 18. Okay. Alright, for 16 and 18, these are the last two I'm going to do for the back side, and then you guys will kind of have to finish the rest of whatever's left over on 1 through 20. So for the first one, for 16, set everything equal to 0, combine like terms if needed. Notice how I need to go ahead and subtract that 2. I have to subtract it from the negative 26. That gives me 0. I'm left with 15r squared minus 23r minus 28 is equal to 0. Once I've done that, I kind of have to see, okay, is there any like terms? Sorry, not like terms, greatest common factors. I cannot do square root method. There is no perfect square minus a perfect square. There is no GCF. If you look at 15, 23, and 28, there is no number you can take out from all of them. That means we're going to be stuck with an a greater than 1 case. When that happens, remember you multiply them to turn a into 1. This will give me r squared minus 23r minus 420. Once I've multiplied by 15, this a is now a 1. But the only way that turned into a 1 was because I multiplied. That means you're going to have to divide by it. So we're left with negative 420. So 35 and 12 gives me 420. But I need it negative, which means one of these has to be negative. Okay, these two. And the 35 actually is the one that has to be negative, because when you add them, you need a negative 23, not a negative 12. So I'm going to make this one negative here. Now I'm going to be left with r minus 35 and r plus 12 is equal to 0. Now, before you can't solve for r yet, because the only reason you're even here is because you multiply by that 15, which means you're going to have to divide like I put before when it's greater than 1. So I'm going to go ahead and divide both by 15. Now remember, I told you if it does not divide nicely, you have to simplify before you cancel your fractions. Okay, so looking at r minus 35 over 15, that actually simplifies to r minus 7 over 3. The second one will simplify to r plus 4 over 5. Okay, so once you've simplified them, notice how from here I simplified first. Now I'm going to cancel out these fractions. So I'm going to multiply this one by 3, okay, because that's my denominator. I'm going to multiply the second one by 5 because that's my denominator. So these are my new two factors. So it's going to be 3r minus 7 and 5r plus 4. That's equal to 0. Now from here, this is where you can actually go and start solving. So your two answers will be r is equal to positive 7 over 3 and negative 4 over 5. And then these are your two answers. So r is equal to negative 4/5 and 7/3. Okay, these are your two final answers. Solutions where you graph the quadratic, it intersects on the x-axis. That's what these solutions are representing. The last one that I'll go over is number 18. So same thing, set them equal to 0. These are not, so I'm going to add 22x to both sides. I cannot add it to any of these two, but I do have to add it to that side regardless. Now that I do that, I'm going to combine my like terms. Remember that you always have to make sure that it's in standard form. Okay, ax squared plus bx plus c. So I'm going to write 12x squared first, then I'm going to write the 22x because that is my bx term, and set them equal to 0. From all of these, I can actually factor out a 2. I cannot do square root method. I can't do perfect square minus a perfect square, but I can use a GCF, which is our 2. I'm left with 6x squared plus 11x plus 3 is equal to 0. Now, if I look at this closely, I still don't have the a equal to 1. That's the purpose of trying to take out a GCF, to try and hopefully get to 1. But your a is not a 1, it's still greater than 1. So we're going to have to repeat what we just did. Multiply the a times the c, that gives you 18. Okay, so I'm going to go ahead and write 2, and then x squared plus 11, let me rewrite that, 11x plus 18. This is our new trinomial. What times what gives you 18, but also positive 11? This will give me 2 times your 9. That's 18. But when you add them, you get positive 11. So I'm left with x plus 2, x plus 9 is equal to 0. Now again, you cannot just start solving and do minus 2 and minus 9 as your answers, because the only way you got there was because you multiplied by the 6. Remember, when it's a greater than 1, you're going to have to divide it. So I'm going to go ahead and divide this by 6. Now looking at those fractions, they don't divide nicely, but they do simplify. You have to simplify first before anything if they don't divide nicely. So I'm going to be left with 2 and then x plus 1/3 x plus 3 over 2 is equal to 0. Okay, now that you've done that, you can clear your fractions and then solve. Now this first one, I'm going to be multiplying by 3. So everything in here will be multiplied by 3. So I'm going to be left with 3x plus 1. The second one will be multiplied by 2 because that's your denominator. So 2x plus 3. And again, I'm not showing the work because I did that in the first one, and hopefully you guys are good from there. Now you can go ahead and solve each one. Now 2 is not an answer, so I'm going to put not equal to, sorry if it's overlapping. X is equal to negative 1/3, and x is equal to negative 3 over 2. So then these are your two answers for this one. And I'll write it here so you guys can see it better. So this one is x is equal to negative 1/3, or let me put, so negative 3 over 2 and negative 1/3. Okay, and those would be your two answers. Again, 0, solutions, x-intercepts on a graph, however you remember your roots. Okay, these are all the same thing. Alright, so this video was a little bit longer just because these questions were a little bit more difficult than the last one. I will work on making the videos a little bit shorter, but in the meantime, go ahead and do 1 through 20. When you're ready to move on, do the next 10 for the next page. Again, the next video will focus on that. If and when you're ready, move on to that. My goal is that you're doing these 10 problems a day for now until we move on to something else. Okay? Alright then, talk to you later guys. Bye.